Okay, welcome to our electricity unit. Electricity is a giant pivot away from what we have been doing so far, which could broadly be called mechanics. In mechanics, almost everything that we did depended upon an object's mass. Everything after kinematics. You remember, we didn't really talk about mass during the kinematics unit when we're just getting used to the ideas of distance, velocity, acceleration, speed, time, stuff like that. But after that unit, once we introduced forces, almost everything had to do with mass. An object's acceleration was often based on its mass. The size, the magnitude of some forces was based on an object's mass. An object's momentum, an object's energy was occasionally based on mass. Mass plays a huge role. In electricity, mass is not, I don't want to say replaced, because it's not like the mass of charged particles doesn't matter, but in terms of importance, mass is superseded by something called an object's electric charge. An electric charge is defined as a property of matter that determines how much an object is affected by electromagnetic forces. If an object has more charge, then there's a bigger effect. Now, this doesn't sound really like a definition, okay? It's kind of circular. The more charge it has, the more electricity affects the object. Well, what is electricity then? Well, it's determined by some property that objects that are charged have. So you can think of it, it's similar to mass in that objects just have it. It's just something that they possess. We don't know why they have it, but they do. So we need to be able to describe it, okay? There's no real reason objects have electric charge that I can give you other than some objects have it, some objects don't. Matter of fact, there's 3 different types of charge. Charge can be positive. We've called, these are the names we've come up with. This one type of charge we refer to as positive charge. This other type of charge we refer to as negative charge. And we even have a name for the lack of charge. Not every particle is charged. Those objects are neutral. So we have these objects in real life, macroscopic, big objects, that might have positive, negative, or neutral amounts of electric charge. Why do they have those? It all comes down to the building blocks of matter. Okay? Why do objects have positive, negative, or neutral charges? At the core, it's because they're made up of different numbers of what we would call subatomic particles that have these different types of charges. Different numbers of protons, those are positively charged. Negatively charged objects are electrons, not neutrons, electrons. And then the neutral charges are neutrons. Okay? So an object's charge is determined by how many protons, electrons, and neutrons it has. Really the protons and electrons mainly. Now, we're going to go back into chemistry a little bit. Nothing too complex, more just the kind of like structure of an atom stuff. Draw a diagram of a typical atom including protons, neutrons, and electrons. So we're going to draw a picture showcasing where these things are in an atom. So first thing I'm going to do is I'm going to make this key. Okay? I'm going to make this key. I'm going to have a colored in circle. That's going to be a proton. A blank circle. That's going to be a neutron. And then a small blank circle. That's going to be an electron. And as you hopefully remember from chemistry, an atom looks something like this. Okay, we've got our protons. They're all kind of jumbled together in the middle. We do have some neutrons separating them to some extent. But anyways, they're kind of packed in the middle. I'm going to do, 6 sounds good. 6 of each. So we've got our protons and we've got our neutrons in the middle in what we would call the nucleus. And then around the outside, we have the electrons. And these are their typical locations. You don't usually see electrons in the nucleus, and you also don't typically see protons outside the nucleus unless it's very rare circumstances. This is the typical picture of the atom that we're used to. Okay, and obviously it's a little bit more complex than this. You learned last year about the cloud model And you did a little bit on uncertainty and stuff like that, and just the location of the atom, or of the electrons and protons and neutrons in an atom isn't super well defined. But that's the basic picture. Protons and neutrons are in the nucleus. Electrons are on the outside in, sometimes you call them orbitals, sometimes you refer to it as the electron cloud, but they're outside the nucleus, okay? In reality, this nucleus is tiny, tiny, tiny. I think it's something along the lines of, if the atom is the size of the football field, the electrons are, on the outer perimeter of the football field. The nucleus is like a ping pong ball resting at midfield or something like that. So the nucleus is tiny compared to the orbits of the electrons. Let's talk about the differences between protons and electrons. And to do this, we can take a look at our reference tables. Oh, don't tell me I don't have my reference tables on me. Oh, this is no good. Okay, I'll run over and get some. Okay. So in this unit, we're going to be looking a lot at the front cover of the reference tables, right here. We're also going to be looking at page 4 of the reference tables. Page 4 has a whole page devoted to electricity. Okay, we will go through everything on this page in about a month. I know it took us like 6 months to go through everything on the back, but now we're going to fly through the reference tables. In any case, let's talk about the differences between protons and neutrons. In terms of their mass, protons are much, much heavier. They have much more mass. Rest mass of a proton, 1.67 times 10 to the negative 27th kilograms. Now wait a second, I just said that protons are more massive. 1.67 times 10 to the negative 27th kilograms, that's tiny. Okay, that's tiny. But compared to the mass of an electron, don't worry about this word rest mass. And a rest mass of an electron is 9.11 times 10 to the negative 31st kilograms. That's way smaller. Matter of fact, we can figure out how much smaller it is by simply dividing those two numbers. 1.67 times 10 to the negative 27th divided by 9.11 times 10 to the negative 31st is approximately 1,800 times bigger. Protons are approximately 1,800 times more massive. I should say that instead of bigger. More massive than electrons are. Okay, much, much more massive. I mean, think about the difference between. I think a good comparison might be like, let's see, a bowling ball is probably about 3 to 4 kilograms for a normal-sized one, and a ping pong ball is somewhere, a few grams. Okay, that would be somewhere, even that actually is probably a little bit. No, that's probably a pretty good approximation. Okay, bowling ball to ping pong ball, comparing those masses. In terms of location, as we already discussed, protons are found in the nucleus of the atom. We know the nucleus is in the center. Whereas electrons are found outside the nucleus, in what we refer to as the electron cloud. As far as the restrictions on protons and electrons, protons are kind of locked in. They can't really leave the nucleus unless it's very, very special circumstances, like radioactivity or radioactive decay. Electrons, on the other hand, typically they're found around the nucleus, but in certain cases, much easier to have cases, electrons can actually leave their parent atom completely, and they can move around. They can go to other atoms, either being shared between atoms or permanently attach themselves to other atoms. Those are situations where you would either call that a covalent bond or an ionic bond when you have ions. So they can leave their parent atoms. Protons really cannot under most circumstances. The big difference, obviously, is protons are positive and electrons are negative. That kind of brings up the question of what a neutron is. We've been ignoring them. A neutron is basically just a proton with no charge. There are some other differences, but the main difference between a proton and a neutron is that protons have a charge, a positive charge, neutrons do not. They even have approximately, it's not really exactly the same mass, but they have similar masses. So that's a lot of differences. But the one thing that these objects, these protons and electrons, the one thing they have in common is that they have the same amount or the same magnitude of charge. The electric charge of a proton, remember that just means amount, magnitude. The electric charge of a proton is, its magnitude, its size is the same as the electric charge of an electron, which seems weird because protons are so much more massive, but they share the same amount of charge. And again, charge is this thing, this property that objects have. We can't really describe it any more than that, but it's the property that is key to understanding electricity. The more of this electric charge stuff you have, the more you're affected by electric effects. Matter of fact, you guys actually know one way to write the charge already for these particles. Last year in chemistry, you said that, if you remember the phrase GENLEP, gain electron negative, lose electron positive, if an atom gained an electron and you were going to write, I think the electronegativity is what it's called, if you're going to write that, you would put a little -1 once it gained an electron. If it gained 2 electrons, you would write -2 or 2 minus or something like that. If instead an object lost an electron, you would say it's +1, it's positive now, lose electrons positive. If it lost 2 electrons, it would be +2, and so on and so forth. What you were counting there was the difference in electrons minus protons. If there was more electrons than protons, then the object had a negative charge. It was charged, there's more electrons than protons, so there's a negative charge on there. That amount of charge, the amount of charge that either an electron or a proton has, is known as an elementary charge. Protons have an elementary charge of +1. Electrons have an elementary charge of -1. So if you think about it, elementary charges are just an easy way for us to count how many electrons or protons there are on an object, or what the difference in electrons and protons are. The symbol for elementary charge, I don't think you used it last year, is E. And again, we talked about this in chemistry last year. An object that has a charge of -1, that just means it has one more electron than proton. That's all an elementary charge is. It's literally like you're counting the difference in electrons versus protons. Okay? Now, in chemistry, that's fine because you're dealing with like individual atoms, and it's not too bad to count the difference in electrons and protons. Okay? In physics, we deal with groups of charge, with objects that are much bigger than just a one electron difference or a positive 1 proton difference. So we actually have a different unit. We still use elementary charges quite a bit, but we also have a different unit for talking about large groups of charge. And that unit is called the coulomb. And it's symbolized with a capital C. Now, on the reference tables, it says that 1 coulomb is equal to 6.25 times 10 to the 18th elementary charges. So let's write that down. We're going to skip this for just a second. 1 coulomb is 6.25 times 10 to the 18th E elementary charges. Okay? Now think about it. That's a whole lot of charges. That's 6.25 followed by like 16 zeros. Okay? That many elementary charges. That means that if you had 1 coulomb of electrons, if you had a charge or a group of charge of -1 coulomb, then that means that there are 6.25 times 10 to the 18th electrons. I'm sorry, you guys can't see this. I apologize. Just realized that. If you have +1 coulombs of charge, that means you have 6.25 times 10 to the 18th protons. Okay, so this many electrons in a group would be a charge of -1 coulomb. This many protons in a group would be a charge of +1 coulombs. Okay, so, and again, remember, when we're counting elementary charges, it's really like we're finding the difference in how many electrons there are versus how many protons there are. Objects typically have like quadrillions and quadrillions of electrons and protons. But what matters is not the number of charges that there are, but the difference between how many electrons there are and how many protons there are. If we know that 1 coulomb is 6.25 times 10 to the 18th elementary charges, that leads to the question, well, how much of a coulomb is just 1 elementary charge? one proton or one electron, what is the amount of charge in coulombs for that? Well, we could find that really easily. We could find that by simply doing one coulomb divided by 6.25 times 10 to the 18th elementary charges. So 1 divided by 6.25 times 10 to the 18th. We end up with 1.6 times 10 to the negative 19th. What that tells us, and this is also on the reference tables, one elementary charge, symbol little e, is equal to 1.6 times 10 to the negative 19th coulombs. 1.6 times 10 to the negative 19th coulombs. That's a tiny fraction of a coulomb. One electron has a tiny, tiny charge if measured in coulombs. And just to give you one more way to kind of think about it, you can use whichever conversion you want, okay? One elementary charge is 1.6 times 10 to the negative 19th coulombs. One coulomb is 6.25 times 10 to the 18th elementary charges. You can use whichever conversion you want. It's very similar to saying something like there's 100 centimeters in a meter, or in 1 centimeter there is 0.01 meters. Those two things mean the same thing. This is similar. If you want a way to think about it, you could think about it like this. Let's imagine I had all these tiny little circles right here. I'm going to take a little second to draw all these in. Okay, so these little circles are representing elementary charges. There's a whole lot of them. Okay, obviously not 1.6 times, or obviously not 6.25 times 10 to the 18th of them, but there's a heck of a lot. These little circles represent elementary charges. This big circle represents a coulomb. A coulomb is a large collection of elementary charges. Okay? So little circles are elementary charges, either protons or electrons, whatever you want. Plus or minus 1e, or plus or minus 1.6 times 10 to the negative 19th c. The big circle is a coulomb. And a coulomb is just a number that we came up with for a large collection of elementary charges. Plus or minus 1c, or plus or minus 6.25 times 10 to the 18th e. Okay, so hopefully you understand the difference between a coulomb and an elementary charge. Elementary charges are very small. It's the amount of charge on one electron. A coulomb is a huge gathering of elementary charges, okay, like absolutely enormous. You do need to know the difference between the two, and you need to know which one you're using when we do some of our equations and math based on electric charge. I'm going to stop there, and when we come back, we'll do a little bit more on charge.